How do medical devices using DICOM exchange information with each other using DICOM associations? I will explain this to you in this video. In the hospital, different types of communication protocols are used between medical devices. So you have the HL7 protocol, which has different flavors, like version 2, which is ASCII based, version 3, which is XML based, FHIR, which is web service based. You also see proprietary protocols, so protocols that are not defined in a common standard. And you, of course, have the DICOM protocol. For the DICOM protocol, you have two flavors. The so-called DICOM associations, which I'm going to explain more in this video, and DICOM Web, which is also web service based. Most of the time, the DICOM service class user is the one that initiates a DICOM association with a remote service class provider. As a DICOM association is based upon an underlying TCP connection, the service class user first needs to connect to a remote IP address and port number. Once the TCP connection has been established, then specific types of DICOM messages will be exchanged. The service class user first sends an association associate request to the service class provider. In the happy flow, the service class provider sends back an association associate accept. After this, several DICOM messages may be exchanged between the two systems, which contain the actual medical data, and at the end, the DICOM association is released. After this, also the underlying TCP connection will be closed. Let's look in more detail at the associate request. Each associate request contains one or more presentation context items. Each item is actually a question from the service class user to the service class provider whether a certain DICOM service is supported. An example of this is, do you support storage of ultrasound? Or another example, do you support the modality work list? When again zooming in on a single presentation context item, you can see that it contains three important parts. The first one is the presentation context ID. This is a unique identification of a presentation context item within a DICOM association. The second one is the abstract syntax, which most of the time is equal to a subclass. So, for example, the ultrasound storage subclass. And the third one is a list of one or more transfer syntaxes, meaning how is the information encoded when sent from the service class user to the service class provider and the other way around. In the associate accept that the service class provider sends back to the service class user, for every proposed presentation context item, the service class provider will indicate whether or not it is supported or not. So this gives the service class user information what actually can be performed together with the service class provider. After the DICOM association has been accepted, different types of DICOM messages may now be exchanged between the service class user and service class provider. Which ones depend on the subclasses that have been proposed and accepted. So, for example, if the ultrasound image storage subclass was proposed and accepted, the service class user can now send CSTOR request messages, and the service class provider can send CSTOR response messages. Another example, if the modality work list was proposed and accepted, the service class user can now send cfind request messages, and the service class provider can now send cfind response messages. If, according to the service class user, no more messages need to be sent or received anymore, the DICOM association needs to be released. So the service class user will send an association release request to the service class provider, and the service class provider will send an association release response back to the service class user. And after this, the underlying TCP connection also needs to be closed. I hope that you enjoyed this short video about diagram associations. Thanks for watching and see you next time.